Good day. We are going to look at galvanic cells. You've kind of been playing around with them on a whatchamacallit, an example thing. And so hopefully you've caught on to some of how they work. So these are your PowerPoint notes. We're not going to be doing all of them to finish out the year. We're not even going to really finish the unit by any means. There's some of the unit we can't get to because it goes on through Gibbs free energy, which we skipped, and so we can't even complete the chapter. So let's go ahead and get started with what we can do. Galvanic cells. A device that changes chemical energy into electrical energy. And electricity is the flow of electrons. So if it's changing into electrical energy, there's got to be a flow of energy and a flow of electrons. So what do these use? They use a redox reaction. And so we're interested in the redox of it. And so here we got redox reaction. And we have the reducing agent. One of the things you're going to be asked to do is you're going to be asked to separate what's the difference between the anode and the cathode. Well, you have to go back and remember oxidation means LEO, or loss of electrons. And so therefore it's an increase in oxidation state because you're losing negatives. And so if it's being oxidized, then you are at the anode. Reduction occurs at the cathode, and that's where you gain the electrons. And when we draw a galvanic cell, we usually put one first and then the other. So we'll see if they've done this example right here. So if the two half reactions are combined in the same container, the electron exchange occurs directly as work is released as heat, and it's to harness the energy. And we keep the half reaction in a separate container so the electron transfer occurs through the wire so we can capture it. By the way, did you see this up here added to the thing? So one of the things I'm going to have you do for homework today is we're going to go clear back to chapter 4, and we're going to practice oxidation reduction reactions in acid solution. So that's going to be your assignment today, but we're going to continue on with galvanic cells the next couple of days. If the two half reactions are combined in the same container, the electron exchange does occur directly as work is released as heat. And again, we want it to occur through the wire so we can capture those moving electrons. A salt bridge, you have to complete the circuit. And so to complete the circuit, you have to have a complete circle for things to travel in, right? Otherwise, you've got an open circuit. And then here's the complete circuit on this one if you have a porous disc. And that's what the complete circuits can look like. So you either have to have a salt bridge or two discs or next to each other with something porous in between to separate them. So parts of a galvanic cell, so notice that you have electrons moving. So this is the reducing agent, which means it's the substance oxidized. This is the oxidizing agent, which means it is the substance reduced. So the substance oxidized, or the electrons are leaving it, is the anode. The substance reducing or gaining electrons is the cathode. So this is key for you to get your homework done today and in the next couple ones. So be sure that you have recognized that. And then that's as far as we're going today. So in the notes. Now what I want to do is I want to flip to your reaction sheet, and I want to walk you through one. You're going to get this example on the homework page too, so that'll help you there also. So we're going to balance redox reactions that occur in an acid. So step 1, you take a look at this reaction and you are dividing it into two half reactions. So I took the manganese And those went together in one half reaction. And then I took the bromine and bromate, and they went to bromide and bromate, and took those. Notice the manganese dioxide is a solid, so it does not have a charge. It would be neutral. And then step 2, now you have to balance the main atoms first. So 1 manganese on each side is what we need. And then we're going to balance oxygens using water and hydrogens using H+, because that's what acids bring to the table when they're in acid solution. So notice I have 4 oxygens here. So I have 4 oxygens here, 2 oxygens here. So that's why I add 2 waters, because that adds 2 oxygens. Well, that also added 4 hydrogens, so I go to the other side and put the 4 hydrogens. Now I am atomically balanced. This one, I have 3 oxygens, so I add 3 waters, so I get 3 oxygens on this side. That also added 6 hydrogens, so I go to the other side and add 6. So step 3 is balance electronically. Here I have +4, -1, +3. Here I have nothing, I have nothing. So I have to make this equal to nothing. So I add 3 electrons to this equation. Down here, I have -1. Here I have -1, +5. I need it to equal to -1 like the other side. So I add 6 electrons. Well, electrons lost have to equal electrons gained. So I'm going to take this equation and multiply it through by 2. So when I do that, I get 6 electrons, 8 hydrogens, 2 permanganates, 2 manganese dioxides, and 4 waters. Here I get 3. I just write the equation down again because I didn't have to change it. Well, now I'm marking out what they have in common. They both have the 6 electrons. That has to be true. And then I have 6 hydrogens down here and 8 hydrogens here. So I'll have a net 2 hydrogens remaining. And I have 3 waters down here, so they're going to go bye-bye. And I will have 1 water remaining up here. So now I am ready to add together. And first off, I want to identify. So notice that this has the electrons going into the equation. So that would mean it's gaining electrons. You have electrons leaving the equation. It's on the product side, so it's leaving. And so this would be the anode. Step 5, add remaining reaction together. So that's what I did. And then we got to check to make sure that everything added up. Okay, I got 2 manganese, 2 manganese, 1 bromine, 1 bromine on each side, 2 hydrogens, 2 hydrogens. 2 times 4 is 8. There is 4 plus 3 plus 1, 8 oxygens. Net charge on this side is a -2. Net charge on this side, it's a -3. Oh, it's a -3 plus 2, so it's a -1. Geez, I didn't even see all these charges. So I have +2, -2, so neutral, -1, and I have a -1. So I have a net charge of -1 on both sides. So it is balanced atomically and electronically. So your job on this worksheet, like I said, I'm just going to give you this worksheet. It won't be all marked up, is to take and do all those steps with that reaction. Okay? So good luck with your work.